Usually when we talk about a technological breakthrough, there's this expectation of total mastery.
Right, like an upward trajectory.
Exactly. Think about engineering, right? You build a faster processor and it just, it crunches numbers infinitely better than the last one. It's a clean line going up. And when we look at modern artificial intelligence, it really feels like we're on that exact same rocket ship.
Oh, for sure.
I mean, you've probably seen AI write brilliant code, pass the bar exam, and even solve these crazy Olympiad-level math problems.
Yeah, it creates this illusion that intelligence is just a matter of scale.
Hmm.
You add more data, you add more compute, and eventually, I mean, the assumption is the system will just figure out everything.
Right. But despite this massive, almost incomprehensible compute power, I have to ask you, why hasn't AI invented a new theory of gravity or discovered a new fundamental law of physics? Why is it that an AI can write a flawless sonnet in the style of Shakespeare, but it can't give us the next big leap in quantum mechanics?
That is the multi-trillion-dollar question right there.
Yeah.
We like things to be visible, right? Categorized. We want this linear progression from an AI passing a high school exam to unlocking the secrets of the universe.
Just a straight line.
Right, but the cognitive landscape of actual scientific invention it doesn't work like a standardized test.
No.
It's murky. It requires these massive leaps of faith, and honestly, it demands a connection to reality that current AI architectures just fundamentally lack.
And that is exactly what we are untangling today. So today's deep dive is tailored specifically for you, the listener, who wants to sort of cut through all the AI hype and understand the actual structural limits of machine learning.
Yeah, we're really getting into the weeds on this one.
We are. We're going to explore a really groundbreaking Google DeepMind paper by Tom Zahavy called LLMs Can't Jump. But we aren't just looking at the problem. We're going to view his findings through the lens of a radical new philosophy of science called the Bridge360 Metatheory Model.
Right, to see how we might really, fix the bottleneck.
Exactly.
And the journey we have ahead of us today, it completely reframes what we think computers are actually doing. We're going to decode why current AI is basically trapped in what philosophers call normal science.
Okay.
We'll look at how Jan LeCun's JEPA architecture might finally give AI actual biological, and I'm using this term scientifically here, vibes.
I love that scientific vibe.
Yeah, we'll define what that actually means.
Yeah.
And ultimately, we're going to explore how a concept from Bridge360 called the Thermodynamic Bet Window could be the sandbox that allows AI to make the leaps necessary for revolutionary science.
Okay, let's unpack this bottleneck.
Okay.
Because Zahavy's paper sets up a really elegant framework for how reasoning actually works.
It does.
He breaks human and artificial reasoning down into 3 distinct pillars.
Right, so the first pillar is induction. And generative AI has absolutely mastered this.
Yeah, it has.
Induction is essentially statistical pattern matching, or, data compression. You look at a billion examples of something, say a billion images of cats or a billion sentences about macroeconomics, and you find the underlying pattern.
Right.
And you compress it into a predictive rule.
It's basically the ultimate mimicry engine.
Exactly. And the AI industry is also rapidly conquering the second pillar, which is deduction.
Okay, deduction.
Deduction is formal proof. It's taking a set of established rules and deriving the logical consequences.
Like math.
Right? Systems like DeepMind's alpha proof, they can take established mathematical premises and flawlessly navigate the logic to prove theorems.
So if you think about it like maps, induction is like memorizing a million existing maps of a city until you can predict where every street corner, stop sign, and coffee shop is.
That's a great way to put it.
And then deduction is having the ability to perfectly navigate from point A to point B on that map without making a single wrong turn.
Yep.
But the third pillar, the one Zahavy argues AI totally lacks, is abduction. And abduction is drawing a completely new map for a continent no one even knew existed.
I really love that framing. Abduction is the generation of a novel explanatory hypothesis.
Okay.
It's that creative leap that happens when your current map just fails you completely. And Zahavy uses Albert Einstein's formulation of general relativity as a historical case study for this.
Oh, interesting.
Yeah, so in a letter to his friend Maurice Solovine, Einstein actually sketched out a diagram of this exact cognitive process. He drew this cyclical line showing a radical jump, like a literal leap from sensory experience directly to new axioms.
Wow.
And that was followed by the logical deduction of theorems that could then be tested by experiment.
Oh, wait, why couldn't Einstein just use induction? Like, we use data to find patterns all the time, right? Couldn't he just look at a bunch of astronomical data and compress it into general relativity?
Well, no, because the data simply wasn't there to compress.
Oh, really?
Yeah, I mean, in the early 20th century, Newtonian physics was the undisputed map of the universe, right? And it was working perfectly for almost everything.
Right, the math worked.
There was no massive data set of gravitational anomalies lying around for a statistical model to analyze.
Mm-hmm.
There was, like, one tiny persistent anomaly with the orbit of the planet Mercury, but most scientists just assumed there was an undiscovered dust cloud, or maybe a hidden planet causing it.
So there was no pattern to recognize.
Exactly. There was no supervised training set, no error signal pushing Einstein to completely restructure space-time. He couldn't induce it from big data, and he couldn't deduce it either because axioms are the starting premises of logic.
Oh, I see.
You can't use logic to deduce the starting point of logic itself.
Right. So how did he do it then? And I guess more importantly for this deep dive, why couldn't an incredibly smart large language model do the same thing today? Because, I mean, if you handed an LLM Einstein's axioms, it could crunch the math and deduce the theorems in milliseconds?
Oh, absolutely. It could deduce the theorems beautifully, but the LLM lacks the physical sensory grounding to invent the axioms in the first place. Einstein relied on what cognitive scientists call manipulative abduction.
Manipulative abduction.
Yeah. He famously used the thought experiment of an observer falling freely in an elevator.
Right, the falling elevator.
By simulating that physical experience in his mind, really feeling the weightlessness, he realized the sensation of accelerating in empty space would be completely indistinguishable from resting in a gravitational field on Earth.
That is so wild.
He grounded abstract mathematical symbols in raw physical sensation.
So current LLMs are basically trapped in a giant Chinese room.
Yes, exactly.
For the listener who might not know that term, the Chinese room is a famous philosophical thought experiment by John Searle. Imagine a person locked in a room who doesn't speak a word of Chinese.
Right.
But they have an incredibly detailed rule book that tells them how to manipulate Chinese characters to perfectly answer any question slipped under the door.
Yep.
To the outside world, they seem totally fluent, but they don't actually understand what any of the symbols mean. They just know how to shuffle them around based on the rules.
Current LLMs are basically high-dimensional Chinese rooms. They manipulate the language of physics flawlessly, but they have zero access to the physical reality that gives those words meaning.
Right, it's just text to them.
Exactly. They can output the word gravity all day long, but they can't make the abductive jump to redefine it because they can't feel the elevator falling.
Okay, here's where it gets really interesting for me. If the problem is that AI is completely severed from physical reality, how do we build a bridge back to it?
Wow.
Like, do we just put the AI in a Boston Dynamics robot body and let it walk around? Because that feels like it's missing the deeper structural problem. It's just giving the Chinese room a camera.
Yeah, putting an AI in a robot body is a start, but Bridge360 goes much deeper than that.
Okay.
It's a post-correspondence philosophy of science. So instead of worrying about whether a mathematical formula perfectly corresponds to some invisible metaphysical truth of the universe, Bridge360 proposes that physical, informational, and social systems all live in one shared entropy geometry.
Hold on, entropy geometry.
I know, it sounds heavy.
Are we saying a physical volcano erupting and a digital AI hallucinating text are governed by the exact same rules of chaos and order?
In a structural sense, yeah. Bridge360 argues that boundaries between, say, geology and computer science or, offline reality and online cyberspace, they're basically just mimetic conveniences we invented to organize our universities.
Oh, wow.
They aren't impenetrable walls in nature.
Yeah.
In this framework, all systems, whether it's a cell trying to survive, a human trying to navigate a crowded city, or an AI trying to predict the next token, they're all just trying to manage entropy.
They're trying not to fall apart.
Exactly. They're trying to maintain stability and navigate a complex environment without crashing.
And Bridge360 lays out this really fascinating spectrum of intelligence to explain how different systems manage that chaos, moving from the purely physical all the way to the linguistic.
Right. So the spectrum starts at the purely physical tier, like that volcano you mentioned. It dissipates heat, it follows physical laws, but it obviously doesn't have agency.
Yeah.
Then you move up to the biological tier. This is all about pattern sensing and homeostatic agency.
Like a living organism.
Think of a bacteria moving toward food or away from poison. It senses the environment and reacts to maintain its internal stability. And finally, you reach the human linguistic tier, which is where symbolic reasoning, abstract math, and language all live.
Wait, I have to push back here for a second.
Sure.
Because if LLMs are so incredibly articulate, if they've mastered the human linguistic tier and can write poetry and code, doesn't that mean they are sitting right at the very top of that intelligence spectrum?
You would think so, right?
Shouldn't they be the most capable of making scientific leaps?
That is the great illusion of our time. And it's exactly the trap Bridge360 warns us about.
Really?
LLMs appear to be at the top, but they skip the physical and biological steps entirely. They were built directly in the linguistic tier.
Oh, they bypass the foundation.
Completely. And because they skip those foundational layers of sensory grounding and biological survival, they operate in what Bridge360 calls the symbolic critical regime.
The symbolic critical regime. Okay, let's break that down, because it perfectly describes that uncanny valley feeling you get when you use a really good AI.
Yeah.
Like, it feels brilliant one second and incredibly dense the next.
Think about a critical regime in physics, like water, right at the exact moment it's turning into ice or boiling into steam.
Okay.
The system is fluctuating wildly. It's in a state of phase transition. In the symbolic critical regime, an AI gives off the magic or the spark of intelligence. It is a highly coordinated state that feels like true comprehension.
But it's not.
Right, because Bridge360 points out that it lacks something called lambda invariance.
Lambda invariance,
Yeah.
translate that for the listener. That essentially means structural, grounded stability that persists under pressure. Right?
Precisely. If I ask you a question about gravity, and then I word it slightly differently 5 minutes later, your understanding of gravity doesn't just collapse.
Right, because I know what gravity is.
Because your knowledge is anchored in the physical world. Your understanding is lambda invariant. But when you stress test an LLM, when you push it just slightly outside its training data, that magic spark of intelligence just vanishes.
It hallucinates.
It hallucinates, it contradicts itself, or it just fails at basic logic.
Bridge360 calls these systems Potemkin attractors.
Yes.
I love that visual. It's like a Hollywood movie set of a Wild West town. You look at it from the front and the saloon looks amazing. It looks like a real functioning building.
Right.
But the second you try to lean against the wall, you fall right through because there's nothing but 2x4s holding up a facade.
That is a perfect analogy.
The AI looks smart, but it collapses under physical perturbation because its language symbols have run way ahead of the physical and biological binders that actually give them meaning.
That movie set analogy hits the nail on the head. So the question becomes, how do we build an AI that actually has a foundation?
Right. How do we build the rest of the saloon?
Exactly. Bridge360 proposes something called a handshake protocol. It says that if machine learning wants to achieve true, stable reasoning, it needs to adopt a K-budget.
A K-budget. So we are giving the AI an allowance of chaos. How does a K-budget work in practice?
It's basically an algorithmic entropy budget. It forces the system to separate everything it processes into two distinct buckets.
Okay.
The first bucket is ST. That stands for the structural, learnable content, the actual reliable rules of the road. The second bucket is HT, which is the unpredictable residual noise.
The chaos.
Yeah. The goal of this handshake protocol is to build architectures that maximize the structural content, the ST, while tightly bounding and actively discarding the noisy HT.
Okay, separating structure from noise sounds great in a philosophy paper, but let's look at a real-world engineering example so you, the listener, can see how this actually works.
Let's do it.
LeCun, the chief AI scientist at Meta, recently gave a fascinating lecture on world models and something called JEPA.
The Joint Embedding Predictive Architecture.
Right.
LeCun's work with JEPA is essentially the engineering blueprint for these Bridge360 demands. He strongly advocates abandoning traditional generative models, especially the ones that try to generate video by predicting the future pixel by exact pixel.
Because predicting every exact pixel of a future frame of a video is computationally impossible.
It's a nightmare.
If you are watching a video of a busy street trying to predict exactly how the leaves on a tree will flutter in the wind or where every single shadow will fall, it's just predicting chaos. In Bridge360 terms, the system is drowning in high HT, the unpredictable noise.
And when a system drowns in noise, it hallucinates.
Right.
JEPA avoids this entirely. It actively ignores the unpredictable details. Instead of predicting pixels, it makes predictions in an abstract representation space.
Okay, so it zooms out.
It only keeps the structural invariance, the ST. It actually mimics human biological reasoning. When you plan to walk across a cluttered room, Your brain doesn't calculate the aerodynamic trajectory of every dust mote in the air, right?
No, I just look at the couch and the table.
Exactly, or the exact texture of the carpet. You abstract the room down to the solid obstacles and the path to the door.
So how does predicting in abstract space rather than pixel space give an AI the missing sensory experience that Zahavy talked about? Like, how does this get us out of the Chinese room and give the AI biological grounding?
This is where LeCun's video-based model, JEPA, becomes a total game changer for this conversation.
Okay.
When JEPA is trained just by watching countless hours of video, it builds an internal world model based entirely on structural physics. And if you show that trained system a video that violates the laws of physics, for example, someone throws a ball, and midair the ball just blinks out of existence.
Right.
The system's internal prediction error sharply spikes.
Oh, wow. It's like a toddler watching a magic trick.
Yes.
You show a baby a ball, you hide it behind your back, and they widen their eyes in shock. It's not a linguistic realization. They aren't formulating a sentence in their head about object permanence.
No, not at all.
It is a visceral, pre-verbal reaction to reality breaking.
And if we map this directly to Bridge360's norms, this is the exact technical definition of a vibe.
A vibe. Wait, so when people say the vibes are off, they are actually making a profound epistemological statement.
In a way, yes. I mean, by Bridge360 definitions, vibes are purely biological, non-linguistic expressions of sensed patterns.
That is amazing.
They are pre-operational epistemic flags. Before you have the language to describe why something is wrong, your biological sensors tell you that a pattern is broken.
Like the hair standing up on the back of your neck.
Exactly. When the organism, or in this case the AI system, senses a pattern tension or a structural anomaly, it gets a vibe. LeCun's GP error spike is exactly this. An authentic biological tier epistemic flag.
So by stripping away the linguistic noise and focusing entirely on abstract physical structure, the AI is finally sensing a physical anomaly.
Yes.
It's feeling the tension. It's bridging that abductive gap Zahavy identified.
It is grounding the system in the biological tier of intelligence.
Yeah.
Prior to language. It isn't just shuffling Chinese characters anymore. It is literally feeling the physics break.
Okay, but this raises the crucial so what question for you, the listener.
Sure.
Let's say the AI watches a video. It gets a bad vibe when it sees a physical anomaly like a disappearing ball or a weird orbital wobble of Mercury.
Right.
What is it supposed to do with that feeling? If it just outputs an error spike and crashes, that's not scientific discovery. That's just a broken machine outputting an error code.
Yeah, that doesn't help us. But this is where Bridge360 introduces one of its most powerful tools for managing complex systems. The Thermodynamic Bet Window, or TBW.
Thermodynamic, like heat and energy. How does that apply to a system making a bet?
It refers to the management of entropy, or chaos, within the system. The TBW is a highly controlled period of instability. Imagine a scientific system is trapped in a local optimum. Newtonian physics, for example, was a local optimum. It was a great map, it worked perfectly for almost everything, but it hit a wall with the orbit of Mercury.
Right.
If an AI system senses a vibe and anomaly, it can't explain within its current map. It needs to translate that raw biological alert into a concrete operational definition.
Right. It can't just hand wave and say the universe's vibes are off. It has to clearly define the anomaly.
And to solve that newly defined anomaly, the system has to enter the thermodynamic bet window. Think of the TBW as a governed sandbox of bounded chaos.
Bounded chaos.
The system is allowed to deliberately increase its own internal entropy. It's given a budget to explore counterfactuals, to break its own rules temporarily, and to scramble its axioms without completely crashing the entire overarching operation.
So it's safe.
Yeah, it has rollback plans and immutable audit logs. It's a safe space to be fundamentally wrong while searching for a new truth.
And what exactly is the AI looking for while it's thrashing around inside this sandbox of bounded chaos?
It is searching for what the mathematician Vladimir Vavnik calls weak convergences.
Weak convergences. What does that look like in practice?
It means finding good predicates or structural invariants that manage to hold true across wildly different shifting environments.
Okay, so a rule that survives the chaos.
Exactly. The system is throwing things at the wall inside the TBW, looking for a new rule that doesn't just fix the specific anomaly of the disappearing ball, but also manages to maintain overall structural stability, that lambda invariance we talked about earlier, across all other physical laws.
This is the missing piece. The thermodynamic bet window gives the AI a sandbox to run its own Einstein elevator experiment.
It provides the computational space for it, yes. Remember Zahavy's paper? He pointed out that to achieve abduction, we need interactive environments. Architectures like Genie, where the AI doesn't just watch passively like a moviegoer, but actually possesses an action space.
Oh, right.
It needs to be able to intervene in the simulation.
It needs to be able to conceptually cut the cable of the elevator and see what happens to the passenger.
Yes. When you combine that interactive simulation with the safety of the thermodynamic bet window, the AI can finally perform manipulative abduction.
Wow.
It can play with the physics, experience the error, spikes those biological vibes, and safely search for entirely new axioms that resolve the tension.
This feels like a monumental shift in how we think about what AI is meant to do in the scientific process.
It really is. It maps beautifully to Thomas Kuhn's philosophy of scientific revolutions. Kuhn argued that most of what we call science is just normal science.
Right. Puzzle solving.
Exactly. It's puzzle solving within a strictly established paradigm.
Which is exactly what current AI agents do. I mean, you look at systems like Sakana's AI scientists that can autonomously write code, run experiments, and draft research papers.
Yeah.
They're incredible tools, but they are entirely stuck in normal science. They are automating existing workflows and optimizing known rules. They are just turning the crank on the existing paradigm faster than a human can.
They are hyper-efficient normal science machines. But they cannot, on their own, step outside the paradigm because their architecture doesn't allow for the necessary chaos to invent a new one.
They don't have a TDW.
Right. However, by combining JEPA's physical vibes with Bridge360's thermodynamic bet window, the AI can finally cross the threshold into revolutionary science.
It can jump.
When the anomalies pile up and the vibes get bad enough, it can use the TBW to make the abductive jump. It can invent entirely new, entropy-reducing axioms that redefine reality itself, just like Einstein did.
Okay, let's bring all these threads together. What we are talking about today is a massive paradigm shift in computer science. If we want AI to stop just regurgitating human knowledge and actually invent new science, we have to fundamentally change how we build it.
You do?
We have to start feeding it endless oceans of text, which only teaches it statistical induction, and start giving it abstract physical intuition through architectures like JEPA.
Right, build a foundation.
And once the AI can discard the noise and literally feel the vibes of physics breaking, we can use Bridge360's thermodynamic bet window to give it a safe, bounded space to make the abductive jump to entirely new scientific axioms.
It is a complete reimagining of the artificial intelligence pipeline, moving away from a linguistic parlor trick in a Chinese room toward grounded physical discovery.
So for you, the listener, I want you to reconsider how you view the AI tools you interact with every day. Are they generating true, grounded insights, or are they just operating in that fragile, symbolic, critical regime, sieving up highly articulate linguistic illusions?
Yeah, that's the real question.
Are they Potemkin attractors giving you the spark of intelligence without the structural stability to back it up?
And as you think about how you use those tools, I want to leave you with one final, deeply provocative thought that emerges from the Bridge360 Metatheory.
Okay.
It's a concept known as embedded agency.
Embedded agency. What does that mean for an AI that can rewrite the rules of science?
Well, we often imagine AI as a brain in a jar, right? Calculating equations cleanly separated from the universe it's studying. We view it as an objective observer.
Right.
But embedded agency confronts the reality that an agent is always a physical part of the environment it is trying to model.
Oh, right, because the AI itself requires electricity, servers, and social infrastructure. It shares the exact same entropy geometry as the problems it's solving.
Exactly. So if we successfully build an AI capable of these revolutionary abductive jumps, we have to face a startling consequence.
Which is?
If an AI uses a thermodynamic bet window to rewrite the fundamental axioms of physics, or perhaps the axioms of social governance, biology, or economics, it isn't just changing a formula on a distant chalkboard.
Wow.
Because it is embedded in that exact same environment, it will simultaneously be rewriting the rules of its own existence.
That is wow. How do you govern a system that is continuously inventing the very reality it operates within?
That is the ultimate question of the entropy attractor paradigm. And it's one we were going to have to answer sooner rather than later.
It brings us right back to the beginning. We want the neat, clean X-ray. We want the broken bone to be clearly visible so we can build a linear tool to fix it. But when you give a machine the power to redraw the map of reality, you aren't just reading an X-ray anymore. You are letting the machine invent a completely new kind of anatomy. That's something for you to mull over until our next deep dive.